Hello everyone. In the previous video, we ran the inference test with SIE in CPU mode, right? In this particular video, we are going to test the same inference engine using GPU. For this, I have already spinned up an instance in RunPod, a GPU instance, and it has 48 GB of VRAM, it's the A40 server, and I have already copied all the code. I have also set up the UV environment, right? All I had to do was to do UV sync, right? And all the necessary packages have been installed. So the next step is to start the server. When we did the CPU version, if you remember, we used the Docker command to start the server, but in this case, command directly. We are going to use the SIE server command directly, and we are going to run it inside the machine. Before we run this, we need to make sure that the SDK is installed, right? And hence, once you have installed it, all you have to do is to just start a new terminal and then run the SIE server command. So we are going to run it in our local host with 8080. Now the server instance has started. The next step is to set up the test. Let's run this with say 10K articles with the batch size of 128. In this case, I'm using higher batch size because we are going to run it in GPU infrastructure, and we also have 48 GB of VRAM to process with. And again, it's running in my local host. No other changes in the code. It's typically the same. If you haven't watched the previous video, basically we are going to download the ArcSight dataset and load and filter the number of articles, in this case 10K articles, and then just generate embeddings using the embedding model. In our case, the embedding model is sentence transformer model, all mini LM L6P2, right? So the setup is going to be similar. However, we are just going to run the inference in GPU. Okay, to run the inference, I'm just going to run Python SIE underscore embeddings.py. As I'm running it for the first time, it's going to download the dataset and it's going to download the model. It's going to take some time, right? But once you have loaded the model once in your SIE environment, you don't have to load it over and over. It just loads it from cache. Okay, the dataset has been downloaded. Right now we have 10K articles loaded up. The next step is to embed these articles. By now, I guess we have the request for loading the model. Here you can see that the sentence transformer model is getting loaded in SIE, right? Once this is done, it has started serving the request. Let's go ahead and see this. And it's super fast, right? Here you can see that we are embedding 128 articles at once. And within 33 seconds, all 10K articles have been embedded, right? Here you can see that output, the 10K articles with 384 dimension with sentence transformer model, 120 is the batch size. We ran it in local machine and we ran it in the GPU infrastructure, but it's local host, right? And the overall time taken is 33 seconds. Okay, in this case, I had access to the server and it was easy for me to run the SIE server command, right? It could be the case that you want to quickly set up in a separate serverless environment. In that case, you can directly use the Docker command. Go to the SIE GitHub repo, and if you scroll down, you will see that we have separate commands for Linux-based environment with already CUDA compiled with CUDA 12, right? So all you have to do is to run this Docker inference, and you'll get the unified API. And then after that, you choose what are the model that you want to run inference with, and then just run the client.encode or extract or what are the command that you want. Right? It already has integration with LangChain, Index, Haystack, BSPU, and other components. If in case you are using any of the frameworks, you can quickly get started by using the integration itself. Okay. So, okay, let's move to the next part, right? In this particular test, we focused more on generating embeddings, right? But the whole point of having SAE server is helps you to have a unified API for multiple models at once, right? So as I said, we can use the same localhost 8080 to serve two different models, one with say the embedding model and other one with say extraction model. To test that, we are going to use an extraction model. For this, I have a sample invoice image. Here I have the sample image, and we are going to perform a zero-shot extraction. For this, what I'm going to do is just use the Grounding DINO base model, right, and pass the images bytes and extract what are the information that I want. So, but in this case, like say I want to extract the invoice number, okay, from this particular invoice. So all I have to do is to use the SIE URL, which is the same URL, unified API, and then convert, load your image, right? In our case, test image, and then convert it to bytes, right? Once you have image as bytes, you basically do the extraction, zero shell extraction using client.extract and pass in the model name, in this case, Grounding DINO, passing the images bytes and what are the label that you want to, right? And you get the result. We are going to get the result as bounding box coordinates. To see whether the information is correct, I'm just going to extract that particular segment alone and then compare, right? So let's go ahead and run the inference for, say, Python SIE underscore extract.py. Okay, as you see, it has loaded the image and it's going to load the model. Let's quickly go to the SIE server and check. Okay, here you see that it has downloaded the Grounding DINO base and then loaded the model, and the inference is done as well, right? Let's go back, and it has returned the bounding box coordinate of invoice number for this particular invoice here, right? Let's zoom in a bit. So ideally we should get 9010. Okay, let's go ahead and check the crop. Here you can see that 901016, so the bounding box coordinate is correct. So that means the model was able to successfully extract the information that we wanted, right? Okay, in case of extraction as well, we have like a lot of different models. You can select extract from the model list, and then you can select what are the model that you want to. Say if you want to extract the information of the invoice in a markdown format, you can do that using Padlo OCR, or you can use GLM model for the same, right? So you can pick different type of models as you want and then perform the task of your choice, and basically with one particular API you'll be able to perform either input or extract or score on whatever the request that you're going to give to the framework. As I mentioned before, SIE already supports Kubernetes based deployment. You can use this Helm command to deploy SIE Inference Engine in production and use it with different models of your choice. I hope this information was useful. Hit on the like button and subscribe to the channel. Thank you very much. See you soon on the next video.